Hi, my name is Faisal Chaudhry, and this presentation is on Lab 2, Lines of Charge. The experiment that was conducted in Lab 2 was by forming two pieces of charged tape, tape A and B, by quickly removing them from a base piece of tape. I placed tape B, my system, on an elevated surface, and I observed its interactions with tape A, the surroundings. A visual depiction of the experiment is shown here. To provide a sense of guidance for this lab, I established some clear goals and assumptions. The goals of this lab were to observe the interactions between two pieces of charged tape and analyzing how charged objects generate electric fields. Also, the goal of this lab was to differentiate between a line charge system and a point charge system. Some assumptions that I made were that the net charge of the system must not change, that the charge of each tape is evenly distributed across their length, and that there is no air resistance in the y direction. Unlike Lab 1, however, this time I am treating tape B as a line of charges rather than a single point charge. In order to justify my findings, I used some fundamental principles, like the universal law of gravitation, where the gravitational force of the tape is the tape's mass multiplied by the gravitational force of 9.81 meters per second squared. Also, I use the momentum principle to justify that the tape's electric force from tape A must equal tape B's gravitational force due to no air resistance in the y direction. I also use Coulomb's law to calculate the electric force of the tape using the constant 1 over 4 pi epsilon naught and the separation distance between tape A and tape B. Now on to the results. I observe that tape A and tape B repel each other, so they must have the same charge. Also, since they attracted to a negatively charged pencil, they also must be positively charged. The length of tape B was 0.2 meters, and its mass was 0.0002 kilograms. Also, the distance between tape A and tape B when tape B started floating was 0.025 meters. Using the law of gravitation, I calculated tape B's gravitational force to be 0.001962 newtons. I set this value equal to the Coulomb's law equation to get the value of the charge of tape B, QB. Since the tape B system is a line of charges rather than a point charge, I multiplied the value I got by the ratio of the length of tape B to the number of segments of the line that I used in GlowScript, 10, to get a line charge of QB equals 2.334 times 10 to the negative 8 C. Now I will dive deep into how my GlowScript code produced a line charge model of tape B. At the beginning of the code, I set the constants that will be used in the following functions in the code, as well as the observed values of tape B's mass and charge. The function down here was obtained from Lab 0, and it basically generates the electric field of the system. This unaltered function generates lines of charge by dividing the charge of the system into n number of particles along a line. Down here, I set the separation distance between tape A, the bottom tape, and tape B, the top tape. Up here, I tampered with the E-scale and FE-scale values until the arrows on the model were clear and visible. Down here, this function iterates through each point charge and adds them together for the model, producing green electric field arrows. And lastly, I created the arrows that would represent the electric force from tape A onto tape B and the gravitational force of tape B for the model. As you can see from the model, there are 10 segments in the line charge model, and the calculated values of the electric and gravitational force are similar to my values, justifying my own calculations. If I model tape B as a single point charge, I would get a charge that is roughly half the charge of the line charge model, given that I multiplied the line charge by the point charge and the ratio of segments to length of tape B. These estimates would differ because line charge systems take into account multiple point charges along the line rather than a single point charge in the center of the line. Also, the line charge model is more likely to be closer to the real value because it takes the relative charges of each segment along the line of tape and adds them together to produce a more accurate net electric field rather than from a single point charge. Generally, a piece of tape also resembles more of a line charge system, so this value would be better representative of the tape's actual charge rather than a single particle in space. And to add on, as more segments, n, are considered in a line charge system, the approximation of the tape's actual charge will be much more accurate. Thank you all for watching.